Hello, in this session I'm going to talk about sets. I'll mainly be going through the basic ideas to get you started with a good understanding of the kind of meanings and notations that we normally use in O-level mathematics. A set is basically a collection of objects. It can be any object that you can imagine. It can be a collection of numbers, a collection of letters, a collection of fruits and chairs and tables and books and pencils and anything you like. So, for example, it can be the numbers 2, 5 and 7. That's a set. It can be the letters A, B and F and G. That's another set. It can be apple, a cup and a sausage. That's a set as well. Just a collection of anything is really quite general. Right, well, we do at O level get questions with sets that are numbers quite a lot. But we do also get questions about other objects sometimes. Right, now when we talk about a set, when we're going to start trying to describe it more carefully, we need to learn some names. Now if I have a set of objects, each object in this set is usually called an element, right? So an object in this set, for example, is called an element. So instead of calling it an object, when you use the word element in mathematics, we understand that you're talking about the thing inside a set, or the member of a set. And we would often represent that a few of these elements belong within a set by using curly brackets like that. So these are called curly brackets, or you can call them braces. So let me write down these words. It's either called a curly bracket, or you can call it a brace. Written like that. So there we have 3 sets. Okay. And having written down a particular set, we might want to talk about it sometimes. We might want to refer to it. It would be quite troublesome if I go around saying my set of numbers 2, 5 and 7, or my set of things apple, cup and sausage. That's quite a mouthful. You have to spell out everything in your set. So what we normally do is we give each set a name. And again, you can call it anything you like. In mathematics, we tend to make it simple by giving it a capital letter. Right, so for example, I might call this the first set A. So the name of the first set is A. So next time I tell you, I mention the set A, you know that I'm talking about the set containing 2, 5 and 7. So that makes it a lot easier. I don't have to go around saying the set of 2, 5, 7 all the time. The next one I might call it E, for example, and the last one I might call it M. So the set, if I tell you that I'm talking about the set M, you know what I mean. I mean the set of apple, cup and sausage. So I don't have to spell out every word for you. So that's naming of a set. So these capital letters there are just the name of the set. Right. Now another thing that we would like to do about the set is that we would like to know or tell how many elements there are in a set. Now if I write out the whole set, then it's quite obvious how many elements there are. In the set A, I have 3 elements. In the set B, I have 1, 2, 3, 4 elements. Right? Now, but if I just tell you the set A without telling you what are the elements, okay, if I don't tell you, if I've not told you about those elements yet, then you would not know how many elements there are in A. So in mathematics, we have notation to represent this number of elements. It's written as, right, it's written as little m, the bracket, and if I'm interested to know the number of elements in A, I put the name A inside. So if I see n bracket A, this means the number of elements. Okay, of course, just writing down this symbol does not tell me what the element is. It simply means that this symbol represents that number. So for example, if in this case I know that the number is 3, I would write n bracket A is equal to 3. So what we are learning here is the meaning of this symbol, little n with the bracket. That's number of elements. Right. Now as a very, very special case, we can imagine having a set that has nothing inside. So it's a bit like you might carry a bag around with some objects inside, and that is like a set, but you might also carry a bag around that has nothing, an empty bag. So an empty set it's can be quite simply represented as using the 2 curly brackets with nothing inside. So it's quite obvious that it's an empty set. Now another way to represent it is by writing a 0 and drawing a line across it. So that symbol also represents an empty set, right? So just a set with nothing inside. Now we are going to go on learning a few more notations, symbols that we can use later on when we answer questions. Now there is this symbol to mean is an element of. The symbol is like that. Okay, sort of like a U rotated by 90 degrees and with a line going through the center. So this symbol means is an element of. How do we use this? Let's look at an example. Right, if I have, say, the set A again, well, maybe not again, but I'll just make up something like 2, 7, and 8. Okay, let's say I have this set A with the elements 2, 7, and 8. So, for example, I know that 7 is an element of A. So I can, of course, just say that in words, but another way to show this idea is to use that symbol there. I can say, write 2 followed by that symbol followed by A. Alright, I was talking about 7. Okay, so this symbol here means that 7 is an element of A. So that's what that symbol means. Okay, so rather than saying out the whole sentence, this makes things a lot simpler to write. But of course, the disadvantage is that you have to remember what that symbol means. Likewise, we have another element which means is not an element of. Now we start with the same element, a symbol as before, but we add a stroke or line across it. So this means it's not an element of. So using that example again, this set A only have the elements 2, 7 and 8. So 3, for example, is not an element of A. So I can write 3 with this symbol A. So this means 3 is not an element of A. Right, the next element, the next symbol is a subset of. Looks like this. So, like the previous symbol, a U rotated 90 degrees, but without the line in the middle. Now, subset means, it usually means a smaller set. So for example, if I look at that example again, A has the elements 2, 7 and 8. Now if I imagine making up a smaller set using, say, 2 and 7. 2 and 7 both belong to A, but it's a smaller set, so I can call it, I can use this symbol here, and write A next to it. And what this means is that this set containing 2 and 7 is a subset of A. Alright, that means that the elements in this set are also contained in A. Now, but although that's usually often the case, the strict meaning of this symbol, the meaning of this word subset, it just means a set whose elements are contained inside A. So for example, a subset can actually be the whole set. Okay, so A itself is a subset of A. So I can write that down. These are special cases. A itself is actually a subset of A. Alright, that's because of the way the meaning of the word subset is defined. It just means as long as I have an element, as long as I have a set whose elements are all inside A, then that set is called a subset. So in the special case when the set is A itself, the elements of A are indeed all inside A. So therefore we can also say that A is a subset of A. It's a special case. Does not mean that A is smaller than A necessarily. Now, another special case is the empty set. The empty set is a subset of A. Now that might sound rather odd. An empty set? Well, an empty set has nothing inside. So it's like saying nothing is part of something. But if you think about it, that kind of makes sense, because if you have nothing, then it can be part of something, right? So in the sense that if you have a set of things and you imagine including nothing inside, it's basically the same thing. Okay, I shan't try to explain further on this, but just take note that we have these two special cases. The empty set and the set itself are both subsets of A. The next symbol is equal to. Now that's very familiar. We have learned all about this in arithmetic and in algebra. Now, but when we use it for sets, we have to be slightly careful. So let me use my old example again. A is with three numbers, say 2, 5, and 7. Right, I have this set here. Now, if I have another set, B, which contains the same element, 2, 5, and 7, then I can use this symbol to say that V is equal to A. That's clear enough. They are exactly the same. But what if I have a set C whose elements are 5, 2, and 7? Is the set C still the same as A? You see, A is 2, 5, and 7. C is 5, 2, and 7. The ordering is different. Well, in the mathematics of set, we say that they are still the same, because a set is only defined or described or specified or determined by what elements it has. Alright, it's not described by the ordering of the elements. So it does not matter how the elements are arranged. If you just imagine, if you have a bag full of things, alright, it does not matter how the things are arranged. It can be in a complete mess, or it can be arranged in a row with some order. So as long as the elements are the same, it does not matter how they are ordered. So therefore, C is also equal to A. So that's an important thing to know. The ordering is not important. Now the next symbol is a curly E. So that's actually an E. Now this symbol is called a universal set. Right, we'll look at some examples in a moment. But roughly speaking, universal set is the largest set that it usually means the largest set when we are talking about something. So, for example, if you are talking about students in the school who play football or who plays music, so the largest set when we talk about the students will be all of the students in that school, for example. Okay, and when we talk about numbers, like numbers 1, 2, or decimal numbers, or negative numbers, and so on. So this would be the set of real numbers. Alright, the set of real numbers refers to all the possible numbers that are positive, negative, fractions and decimals and whole numbers and integers and so on. So these are universal sets. Of course, we can always think of a set which is bigger than the universal set that we're talking about, but the universal set is normally, it has to be defined, specified for a particular problem, and you would usually just think of the biggest possible set that you're interested in. So we'll look at some examples in a moment. Right. Now next we look at the problem of how to describe a set. Right, actually we are going to look at the notations we need to use to describe a set. Right, we can always describe a set verbally, or we can try. For example, let's think of all the numbers that are between 1 and 10. Okay. Right. So I can describe this in words, of course. Now, but if I describe it in words, it tends to be quite long, and in mathematics we often like to have notations to make it shorter and simpler to describe. So I could use algebra, for example, to represent a number x. So that's my number, And if this has to be between 1 and 10, it means that it has to be more than 1 and less than 10. And if I'm interested to say that this collection of all these numbers in between 1 and 10 belong to a set, right? Or that a set contains these numbers, then I would write it this way. I would put let's see, I would put an X before that with a colon. Alright, so it just means that X is the element of this set. Colon means that X obeys that condition, and the condition is that X must be between 1 and 10. And to show that this is a set, we put curly brackets around the whole lot. So when you see this funny notation right within the curly brackets, you have an X and you have a colon, then whatever comes after the colon is the condition that tells you the rule, alright, that X must obey. So in this case, what it means is that as long as a number X is between 1 and 10, then all of these possible values of X belong to this set. So this is a, well, I would say this is a shorter way, definitely, of describing this set compared to writing the whole thing out in words. But of course, if you're seeing this for the first time, it can look really confusing. But we'll get used to it with some examples. So if, right, so that's one example. Let's look at another example. So let's say following on from this, I'm looking at X that is between 1 and 10 again. Now, but this time I'm only interested in X that are positive whole numbers, right? So now the positive whole numbers let me represent this set of positive whole numbers by the letter N. So let's say I have this set N, which refers to positive whole numbers. Right. So actually positive whole numbers, another name for the set of positive whole numbers is natural numbers. Okay, that's why I use the capital letter N to represent this set. Now suppose that I'm interested in a set in which the elements X is a positive whole number and it is also between X equals to, it's also between 1 and 10. Now the way that I would describe a set, alright, where X is a positive whole number is to say X is an element of N. And if it is also between 1 and 10, I would then write a colon after that and then 1 less than X less than 10. And to show that this is a set, I put curly brackets around them. So now I have again a short compact notation that tells me, that describes this set, right? Rather than saying that X is a positive whole numbers and and it is between 1 and 10. So that's a very long sentence. I write it down this way. I write using the symbol, this symbol, and those symbols. And if I read this out in English, what it says is that, well, with the curly braces, it tells you that it's a set. So this is a set of X, which is an element of the set of positive whole numbers, and it obeys the condition that X is more than 1 and less than 10, meaning that it is between 1 and 10. So notice that to describe the whole thing in words, I need to say many words. It's a pretty long sentence. So this way of doing it using the symbols is quite short. It gives us a short and quick way of writing this down. And the main thing to learn here is to understand the meaning of each symbol and understand what it means when we put the whole lot together. Next, we are going to look at Venn diagrams. Venn diagram is a way to represent the set, to visualize the set using pictures. So that's the easiest way is to look at some examples and draw some pictures directly. So just as an example, I'm going to start with a universal set represented by the curly E that consists of the numbers, right, 1, 2, 3, 4, 5, 6, 7, 8. Right. Just the 8 numbers there. So notice that what I'm doing here is I'm defining my universal set. So this is something that we do. It's the largest set that I'm going to use. Alright? Whatever set I'm going to talk about next, I'm just going to make up or look at sets that are smaller than this and that contain these elements here. So that so I would not want to talk about other numbers in this particular discussion. Right, so if you like, that's how we can think about universal set. You just make it up, you just decide on the biggest set or the biggest collection of objects that you think you are interested in, and then you just discuss it or think about it or calculate with it. So right, that's my universal set, and I'm going to define some sets inside this universal set. So I'm going to define a set A. Okay, and the set A contains the elements 2, 4, 6, 8. Okay, so I have 2 sets here. Now I want to represent this using a picture. So what I could do is I could draw a rectangle and say that this rectangle represents the universal set. Okay. Now since A have elements that are inside the set and A is also a smaller set, I can represent A with a shape inside the rectangle. Okay, so we represent the idea that A is a smaller part of the set E of the universal set by drawing a shape within a bigger shape. So that's the pictorial way of doing it. So that's my A. Okay, and I can, just to make it quite clear what this means, I can write out these elements in the picture. So A is 2, 4, 6 and 8. I can write 2, 4, 6 and 8 inside the circle. And outside, but still within the rectangle, I can write out the rest of the elements, which would be 1, 3, 5 and 7. Right? It does not really matter where on the picture I write these numbers, as long as they are within the right region. Alright? So the elements of A should be inside the shape of A. The elements that are not in A should be outside the shape of A. But everything should be within the biggest rectangle, the big rectangle, which represents the universal set. So everything is inside the universal set. We're not interested in things that are outside. So that's a Venn diagram. Right? The name given to such a picture is a Venn diagram. Right, now let me think of another set. I call it the set B, which is equal to 2 and 4. Now you can see that B is a subset of A. Alright, it's smaller than A and both the elements are in A. Now if I want to show that on the Venn diagram, what I could do, I notice that I already have the 2 and 4 there. I could just draw a shape around it, some sort of a ellipse, and that's my B. Okay, so now I have a Venn diagram for this picture for the subset of A. Just a smaller shape within the circle of A. Let me clear this now. I'm going to make up another set C, which I call, which contain the elements 6, 8, 5 and 7. Right. So now I want to draw a Venn diagram for A and for C. I have my universal set E. I have the set A. Now we have to be careful here. Notice that A and C have the elements 6, 8 in common. Alright? But the element 5, 7 and 2, 4 are not in common. So when I draw the shape of A and C, I must remember that there are some elements that are the same but some elements that are different. And the way to draw such a picture is to draw two overlapping shapes or circle. Okay, and in the place where they overlap, we write down the elements that are common, 6 and 8. Okay, and outside of that overlapping region, we have 5 and 7 for C. That means that 5 and 7 are inside C but outside A. Whereas A would have 2 and 4. 2 and 4 are inside A but outside C. So this is how we would represent two sets that have some but not all of the elements in common. Okay, and now, and you notice that there is this overlapping region here. Now there is a symbol for that. It is called intersection. Let me write that down. And the symbol is an inverted U. Right? So in this case, I would write this overlapping region and the two elements there using A, the symbol for intersection C. So this means A intersects C, and it refers to the common elements 6 and 8. The 6 and the 8 here. Okay, so A intersect C is the set of elements that are present in both A and C. So that's intersection. Now we can have another symbol called union, which is represented by the symbol U. Now union refers to all of the elements in the two sets. So if I write A union C, okay, that would include all the elements. So it would include 2, 4, 6, 8, 5, 7. That's union. Now we are going to learn one more symbol. That symbol is called complements. Now, the symbol is an apostrophe. So that's a rather odd symbol. Now let's see how you would write this. Let's look at the element A. Okay, if I write down A apostrophe, it means A meaning complement. It means all the elements that are not in A. So A contains these elements, A apostrophe contains the rest that are still in the universal set. So this would be, or it would not be 2, 4, 6 and 8, so it would be 1, 3, 5 and 7. and A complements. And where would this be? Now if I draw the circle to represent A, which contains all those elements, then A complement refers to the region outside the circle. So we can imagine that the area inside the circle represents A, and the area outside the circle represents A complement. Right. So because of this idea about the area representing the set, it is often convenient to shade the regions that we are interested in. So for example, if I'm interested in emphasizing or showing this particular set A complement, I might do it by shading the region that represents A complement like that. So in the exam questions on set, you might sometimes see a picture with some shapes on it and with parts of the area shaded. So this is what it means, alright? It means that it's highlighting a set that corresponds to that area. So in this case, the shaded area here will correspond to A complement, meaning the set that is the set of elements that is outside A, that does not include the elements of A. Right, so let's finish off by looking at some examples about this shading idea. Example. Universal sets. Let's look at this picture. The question is to represent the shade, the set for the shaded area using set notations. Now, what do we mean set notation? Set notation means what we have just seen, like intersection, the symbol for union, the symbol for complements, the symbol for okay, we don't need subset and elements here, right? So it would be mainly complement, union, and symbol, union and intersection, and the names E, A, and B. So let's write down the thing that we need to use. We need to use symbols E, A, B, intersection, union, and the apostrophe, the complements. So using these notations, we have to make up something, string them together somehow to give something that is equal to a set corresponding to the shaded region. Right, so let's try and do that. Now, that's a rather odd looking shaded area, but what we could do is we could look at the unshaded area. Now, A is not shaded, right? B is not shaded. Now, the whole of this unshaded area is actually contains all the elements in A and in B. Now, if you remember, that means union. A union B. So A union B is actually the unshaded area. Okay, but that's not what we're interested in. We're interested in the shaded area, which is everything outside A union B. Now, but we have just learned what that is. That is the complement. So everything outside A union B is, well, we need to put a bracket around it to make sure that we include everything. A union B, bracket, complements. So this describes the shaded area. So that's how we do this particular question. Let's look at another example. Right, that's the shaded area now. So again, another rather oddly shaped region. Looks like a moon, right? So how are we going to make up a symbol, some notation to describe this set? So we think of this region as, right, let's look at the whole circle here. The whole circle is the set B. Now, but in this case, the shaded area is less than B, is less by this bit here. Okay, so how can we represent that? Right, let's try this. The shaded area must be inside B, right? The shaded area must be outside A. Let me write those down. It must be inside B. It must be outside A. Now, outside A is given by that symbol, the complement. So A complement is outside A. Okay, so A complement means everything that is outside A. B means everything that is inside this B circle. So it must be both. The shaded region is within B, is in the set B, and it is also in that set A complement, meaning that it's outside of the A. So because the shaded region must be in that set and that set is common to both sets, we use intersection to represent that, because that's what intersection means. The elements that are common to two sets, right? And that's the answer. B union A. Oh, sorry. B intersect A complements. That's the answer for this. Okay, we'll stop here for this session. See you next time.